Problem 112. We had this problem before, but here we need to analyze the acceleration of it too. Previously in problem 81, we had this mechanism. OA is rotating with angular velocity of 9 radian per second in counterclockwise direction, and B has to move just in the horizontal direction. Previously in that problem, we found that omega of AB is going to be equal to 4.16 radian per second. Now in this problem, it is asking what is the angular acceleration of this link? What is alpha of AB? Okay. So I'm going to assume you know how to calculate omega of it, but just shortly to remind you, if I write the relative velocity equation between A and B, because I know velocity of B is gonna be in the horizontal direction, and also velocity of A is gonna be 80 times 9 radian per second, and the velocity is gonna be upward, then in that relative velocity equation, I'm gonna be able to find omega of this link, AB, and also the velocity of B. Also, you can use the instantaneous center of rotation or instantaneous center of zero velocity of this link. So you know the direction of velocity of A, draw a perpendicular line to it. You know the velocity of B must be in this direction, draw a perpendicular line to it. So this point is going to be the instantaneous center. Because you know the velocity of A divided to this length, you are going to be able to find omega of AB using the instantaneous center. Anyhow, I assume you know how to find omega. So after finding this omega, now the question is how we can find alpha of this link. So please stop this or pause this video and try to solve it yourself and spend at least 10 minutes on this problem. Okay, now how we can solve this? Again, similar to what we did for the velocity, if you write down the relative velocity equation between A and B, alpha of this link is going to show up in that equation. Let's write it down. Acceleration of B is equal to acceleration of A plus alpha of this link, alpha of AB, as a vector, cross product to AB, minus omega of this link squared times AB. This is the relative velocity equation, right? Now, let's count how many unknowns do we have here. Acceleration of B, we know the direction of it, but we don't know the magnitude of it. So acceleration of B as a vector is going to be AB times I hat. So we have only one unknown here. Acceleration of A, we know everything about A. I'm going to come back to that later, but we have everything about acceleration of A. Alpha of this link, we don't know it, but we know it's going to be in the k direction or negative k direction. So we have only one unknown here. Vector AB, you can write it simply in vector form because we know all the dimensions. Omega, we found it in the previous problem, and also AB again is this vector. So we have only two unknowns here, the magnitude of acceleration of B and also the magnitude of the angular acceleration. And this is a vector equation in 2D, so we have two equations here too. Two equations, two unknowns. So we should be able to find both unknowns here, right? So let's fill in what we have here. Acceleration of B is going to be AB, just in the I direction. Let's specify what is I, what is J. This is X and this is Y direction. Always show your coordinate. Is equal to acceleration of A. Now look at point A. A is moving on a circle about point O with the constant angular velocity of 9 radian per second, right? Because A is moving on a circle, in general, it's going to have two accelerations, right? Or the acceleration of it has two components, tangential part and also the normal part. The tangential part of the acceleration is going to be r times alpha of this link, which is 0. So acceleration of A in the tangential direction is 0. In the normal direction, acceleration is velocity squared divided by r, or r times omega squared, right? So acceleration of A, because it doesn't have any tangential component, all of it is going to be just in the normal direction. And the magnitude of it is going to be 80 millimeter times 9 squared in negative I direction, right? So let's write that down. So we are going to have negative 0.08 meter times omega squared, 9 squared, in the I direction. That's acceleration of A. Plus alpha AB, we don't know what is alpha, but the direction, because it's a planar motion, direction is always K, positive or negative, right? Cross product to AB. And AB, we know this is 200 and this distance is 100. If we calculate this angle, sine of this angle is 100 divided by 200, 1/2. So this angle is 30 degree. Same thing here. This angle is 30 degree, right? So AB is going to be 200 times cosine of 30 in the I direction, 200 times sine of 30 in the J direction, millimeter. So if I make it meter, it's going to be 0.2 cosine of 30 in the I direction plus 0.2 sine of 30 in the J direction. Okay, and then we have this part as well, minus omega AB squared, so negative 4.16 squared times AB again. So again, 0.2 times cosine of 30 I hat plus 0.2 times sine of 30 J hat. Okay. Now, how many unknowns do we have here? Only 2. Acceleration of B, just the magnitude, and the magnitude of the angular acceleration. So you need to do this cross product and separate I and J terms to construct your two system of equations. So separate I, J terms, which I'm going to let you do that yourself. Then after finding the unknowns, you need to check if this acceleration of B must be equal to negative 10.47 meter per second squared, and alpha of AB must be 9.98 radian per second squared. And because it turned out to be positive, it means it is counterclockwise.